Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. We are going to be treating non-parallel coplanar forces. Haven't treated parallel coplanar forces, but then let's get started. By the end of this lesson, you are going to be able to define parallel coplanar forces. You are going to define non-parallel coplanar forces, and you are going to state conditions for bodies to be in equilibrium under non-parallel coplanar forces. You are also going to state the moment of forces. You are going to solve a few problems on equilibrium of forces, and also we are also going to take few more examples from Examguide app. Let's move on. All right, when we talk about non-parallel coplanar forces, we are saying that a non-parallel coplanar forces are forces that lie in the same plane and whose line of action intersect at a common point. Look at this. When we treated parallel coplanar forces, we said that this is an example of parallel coplanar forces. Maybe we have an option, upward force, maybe call it R1, and maybe a point here. We also have another one, maybe let's say the force is, let me use numbers in order not to confuse you. Assuming we have 80 Newton upward, let's say 100 Newton downward, and maybe another force is acting here, maybe let's say 10 Newton, and then we may be asked to find weight. You see? Now, if you look at this one, we call them parallel coplanar forces in the sense that their line of actions, look at the line of action on 80. 80's line of action is on this direction. That is the weight line of action is on this level. This 10 Newton's line of action is on this level. And 100's line of action on this level. You see, all of them are parallel to each other. Their forces, their line of actions are very parallel to each other, and that all of them are also lying on the same plane called plane AB. So when you have this kind of condition met in a problem or moment of forces, or for a body to be in an equilibrium, when their forces are parallel to each other, the line of forces are parallel to each other, we say we have parallel coplanar forces. But when they are not parallel, then you have a condition like this. Like the one you are seeing on the screen is a perfect example. But let me show you. If you have a plane, then a force is acting on this plane. Probably a rope is tied through a tension. That because whenever you use a rope to pull a body, the force acting on the rope, acting on the body, is called tensional force. So that is why you always see T like this. Now this is a rope. Maybe they tie a rope on this place and they are pulling it. Maybe the weight of the body must be considered also, you see, and then make other things. If you check very well, the line of action of this tensional force is the rope meeting at the point of action of this weight. So there is a point of intersection between the tensional force, that is the rope, and this weight of the meter rule. So when their point of intersection intersect, we say we have a non-parallel coplanar force. Look at the picture you have on your screen. I'm also going to use that one to throw more light on the condition. If you have this point, then the line of action at this point is in this direction. This is the line of action in this direction. And then another force is applied in this direction, F2. This is F2, that is the second force. This is F1, the first force. The line of action of this force is on this direction. You see, they meet at this point, and that is the point of intersection, and that defines what a non-parallel coplanar forces are. Let's move on. Then there is something else we call concurrent forces. Concurrent forces. It said a set of point forces is considered concurrent if all the lines of action of those forces all come together at a single point. You see, I don't really like it when people, when you are studying physics or you're in a physics class, when things like this happen and we will not be able to bring it down to a real life situation. When you see when you see this kind of diagram, it can happen. You can have a load. This is a load of weight. Whatever the load is, you see different wires. Maybe a wire is holding in this direction, holding it upward. Another wire is holding it in this direction, which is F2. Then there is a force keeping it this way, which is 8 Newton. Then you also tie another force, maybe another rope on this direction. If all these forces, all of them acting, coming to a point, see their line of action meeting, this is, let's say this one is not going to be here, this is going to be in this direction, 8 Newton. Yes, 8 Newton. Now, if all of them, their line of action meeting at a particular point, we said that the forces acting on this body of mass, they are called concurrent forces because their line of action came together to a point. That is what we mean by that, concurrent forces. All right. Equilibrium condition that can be used for non-concurrent, non-parallel forces. Number one, the sum of all forces in the x direction or horizontal direction is 0. Look at this. I know you have always seen this. This is very confusing, right? What does that mean? It means that, let's assume we have, let's assume that you have, let's say, this diagram. Look at this, all the forces acting on the body, F1, F2, maybe F3, all right? Now, remember that in this case now, okay, no, let me not use this one. If assuming that this is a body and the force F1, another force F2, and then another force is also helping the F3. Now, all of them are on the horizontal direction, right? Now, remember that F2 and F3 is likely to be more than this, depending on the magnitude of the force. For example, if F2 is 80, F3 is 20, and then F1 is maybe 70, you know that all of them here are greater. Now, look at this sign, sigma. This sign, sigma, means that you are adding all the forces together, right? Now, look at what this expression always means. And whenever we are talking about force or vectors, remember that the direction or the motion of the body you are pulling must go in the direction of the bigger forces. Because if somebody is big and he has enough force, and he's doing a tug of war with somebody who has a very low force, of course, he's going to pull him to his direction. The same thing happens on a physical things. When you have rope or whatever, pulling this body is going to move in this direction. And if that is the case, we are going to say that 80 plus 20. Now, look at the direction of the 70. The direction of the 70 is in the opposite direction to this 80. So we are going to put minus plus, no, we are going to say plus minus 70, all right, is equal to 0. All right? So if the sum of all the horizontal forces, okay, let me not put this one 70. I'm going to call it F1. You see? F1. If I say this plus this, whenever anyone is moving in opposite direction, remember the vector. Whenever something is going opposite direction, it's going to have a negative sign. Now, there is one little misconception people have on physics. When you are treating graph, you say that every time you draw graph in mathematics, that on the right-hand side of the origin is positive and the left-hand side is negative. That is only in your math, so it's not in physics. In physics, any direction you choose to be your positive direction becomes it, because it depends on where you want to pull your body to. It depends on the direction you want your body to be dragged to. So you have to make your choice to say, my positive x direction is going to move in this direction. But this one I'm doing, my positive direction, I am choosing it to go in the left-hand side of your screen. So you're moving in this direction. So that is why the one now moving in the positive direction, I choose it to be my negative. That is why this F1 moving in the east direction is -2. So when I add all of them together, I'm going to now say that 80 plus 20 is going to be 100. It's going to be equal to minus here, growing here becomes plus. So we say that F1 is 100 Newton. That is the only force that can balance this one moving in this direction. That is the essence of saying sum of all the forces in the horizontal direction is equal to 0. Now, the second one is sum of all forces in y direction or vertical is 0. The same thing. When you take the vertical component of all the forces, then equate them to 0. That means if you have a body pulling upward, maybe you have normal reaction, R1, this is R1, R2, and then maybe weight, the weight of the body. Now, how do I say that sum of all the forces in the y direction or vertical is 0? So your textbook will always write this. Your textbook will say Fy is equal to 0. But what does that mean? It means that the ones moving in the positive direction and the one moving in that direction, if I'm moving in the positive direction, I'm going to say that R1 plus R2 minus W, because it's moving in opposite to my direction I'm moving. If all of them will be equal to 0, that means, do you know why they must be equal to 0? There is no motion. Okay, not really there is no motion, because it may be moving, which is called dynamic equilibrium, that the body is not accelerating. The body is not accelerating. So, but if the body is accelerating, we are going to have a net force. Remember, we are treating equilibrium. Two kinds of equilibrium. Static equilibrium and dynamic equilibrium. Static equilibrium means, according to first law of motion by Sir Isaac Newton, who says that the body can never shake or move. But if the body is already moving, if the body is already moving, that it will continue moving till eternity. Now, that means that there is no net force. What do I mean by net? Change. So that means no bigger force is acting more than the other. So all the forces acting together must be 0. That is the essence of all these mathematical functions that they write. But we are going to see how we are going to apply them in a real problem to be able to solve. And then lastly, he said that the sum of moments at any point O is 0. That means clockwise moment must be equal to anti-clockwise moment. That means everything sum up to 0. Now, we have a problem at hand. The body is in equilibrium. That is the number 1 point. The body is in equilibrium. All right. Now, look at that example, number 1. If the body is in equilibrium by the action of the rope, T, find the tension in the rope. Like I told you, a tension is a force which is acting on a rope applied to a body. So how are we going to do that? Let's check. But then remember that, you see, the essence of physics is that there is a principle for you to follow, and you must not go outside those principles. If you do, you fail. That is the principle. The principle has made it clear here that all the forces on the x or the horizontal direction must be 0, or all the forces on the vertical direction must be equal to 0, or that the moment of forces about O must be 0. Now, The last statement, I don't think is applied in this principle because there is no moment, no turning. When we talk about moment, we are talking about turning point or a point of rotation. So condition number 3 is never going to be applied in this direction. Now, what about condition number 1? The sum of forces in the x direction. Do we have any force on the x direction? No. That means you are left, we are transfixed with this one. All the forces in the vertical direction must be equal to 0. Let's see how that can be applied in this principle. Now, for me to be able to achieve this, I have to find all the vertical forces. All right? That means whenever you see an angle and a force, it means that the force is not effective. It's not an effective force. There are 2 basic effective forces, which is called vertical component and horizontal component. To know more about resolution of forces, you have to study the lesson I have done on vectors. Now let's see how this works. Look at what happened. This is the y-axis, and this is the force acting on the y-axis, 60 degrees, and under this tension. How can I resolve this force to vertical? Because I want to say that the sum of all the vertical forces must be equal to 0. What do I do to this part? I'm going to say this. I'm going to do a vector projection, all right? I'm going to project this vector to the vertical component, and I have a right angle triangle. In this my right angle triangle, I'm going to apply trigonometric ratios in order to find Fy. According to trigonometric ratio, as I'm going to use K. K means that the cos of the angle 60 is going to be equal to, adjacent is this one, which is Fy, all over T, which is the hypotenuse. Therefore, I'm going to say that Fy is going to be T cos 60. That is the first one. Remember, there are 2 T's because it's not just one rope, there are 2 ropes. Now, that means the other one too is this direction. Look at this, and this is vertical. I'm going to do projection Fy 60 degrees, and T is still going to be, that is the first one, Fy1, then Fy2 is going to be T cos 60. This is another upward force. So I have 2 upward forces. Now, according to this principle, the 2 upward forces must balance the 2 downward forces. So I'm going to have Fy1 plus Fy2 minus, why am I using minus? It's moving opposite direction to my upward forces. Minus 2 is equal to 0. That is the meaning of summation Fy equal to 0. So Fy1 is T cos 60 plus T cos 60, which is equal to 2. Why? I have to move these 2 to this side. It becomes positive. Now, at this point, I will have to solve a simple arithmetic. So T cos 60, T cos 60. Cos 60 should be, if sine 60 is 0.860, that means cos 60 is going to be complementary angle, is going to be 0.5. So I'm going to have T over 2 plus T over 2 equal to 2. I'm going to clear the fraction by multiplying each of them with the LCM, which is 2 times 2 times 2. So I'm having 2 will cancel 2, 2 will cancel 2. T plus T is equal to 4. T plus T is 2T is equal to 4. Divide both sides by 2. T is going to be 2 Newton. That means a force of 2 Newton was used on the rope in order to hold this load of 2 Newton in a equilibrium by the action of all these 3 forces called non-parallel coplanar forces. All right, we have another example. He said a body of mass 10 kg is kept in equilibrium. Very important. You see, if you give me this question and you don't put equilibrium, I cannot solve it. I am not going to, because the topic is on equilibrium, because I see a lot of some of these exam bodies, they will bring a question and want you to solve it without giving the basic condition for it. So you must always see equilibrium, because that is the condition where these our principles are applied. Now, a body of mass 10 kg is kept in equilibrium by two ropes as shown below. If one rope pulls the body in a horizontal direction and the other in a direction 40 degrees with a vertical, calculate the tension in the rope. All right. Okay. There are two ropes. The best thing I have to do is also resolve my forces into vertical and horizontal. These are the two most effective forces. Now, to resolve this is 40 degrees, sorry. To resolve it vertically, I'm going to call this is vertical, which is Fy, and this is horizontal, which is Fx. Remember that they are parallel to each other. So now, what am I going to do? And this is angle 90. I have completed a triangle. We call it vector projection, if you have done your further maths very well. So in this case, I am going to resolve it vertically and horizontally. Which one is my vertical? Fy is my vertical component of the force, and this is T2. I'm going to have Fy is adjacent, and this one is hypotenuse. I'm going to have T2 cos 40. That is the first one. That is my vertical component. And my horizontal component is going to be, this is opposite and hypotenuse, is going to be T2 sine 40. You also have to study your trigonometric ratios very well for you to fix in here very well. So I have resolved that. At the end, this is what I'm going to have. The one on the vertical axis, which is Fy, is going to be at this direction, which is T2 cos 40. And the one on the horizontal direction is going to be at this direction, which is T2 sine 40. And the one moving in this direction is T1. And the one moving direction is 100. Now look at this. I have upward forces are T2 cos 40 and 100 Newton is going down, while this one is moving in direction. Now for me to be able to find the tension in each rope, I'm going to say that upward force, this minus this, equal to 0, because that is going to be my Fy equal to 0. So I'm going to consider only these vertical ones. If I'm using this, I'm going to say 100 minus T cos 30 equal to 0. Or I'm going to say T2 cos 40 minus 100 equal to 0. And that's what I'm going to do. T2 cos 40 minus 100 equal to 0. That means T2 cos 40 is equal to 100. That means that my T2 is going to be 100 cos 40. T2 is what? Use our calculator to find the angle of cos 40 degrees. Cos 40, 0.766. I'm using that. 100 divided by 0.766. So, if you do this very well, you are going to have 130.5 to 1 decimal place Newton. That is the force on T2. Sorry, that is T2. Now let's find T1. Remember, T1 is on the horizontal axis. I'm going to say that T1 minus T2 sine 40 is equal to 0. All right. T1 is going to be T2 sine 40. And T1 is going to be, T2 is 130.5 sine 40. T1 is going to be, so 130.5 sine 40 is going to be 83.9. So 83.9 Newton. This is the answer to this question according to the principle of moment. Thank you. We have come to the end of this lesson. But remember, before we go, we have to take a few more examples and questions from Examguide app. So let's go to Examguide app for more questions. Okay, we are now in UTME Examguide app. Let's look at a few questions for our non-parallel coplanar forces. Okay, now this question, let's look at the first one. It says all the three forces must be concurrent. You know what concurrent means? Concurrent means that all the forces their line of action must meet at a point. That is what we mean by concurrent forces. Now, the upward force is equal to the downward force. Of course, that one is a condition for all of them. The algebraic sum of the moment about any point must be 0. Yes, that's correct. Which of the above condition must hold for a body acted upon by a system of three coplanar forces in equilibrium? I will take the three of them. The three of them are correct, and that is true. Sum of all forces acting on a body is 0. This condition represents equilibrium. First condition. Who cares about whether it's first condition or second condition? The law is the law. Okay, let's say it's first condition. Sum of all the forces must be equal to the sum of the maybe they're tired of asking questions. Sum of all the forces acting on the body, this represents the first condition. Okay. Okay, let's look at this one. Yeah, let's look at this question. We have, he said, if the above system is at equilibrium, the value T1 and T2 are. All right. We have this is 60 and this is 45 degrees, and this is a weight of the body they are holding, 100 Newton, and this is T2 and this is T1. All right, so this is the line of force. This is the line of force of 100 Newton, and let me complete this one. All right, now if I should do this one is parallel to this is going to be 60 degrees and this is going to be 45 degrees. Why did I do this? Because they are alternate angle. Look at the Z. 1, 2, 3. That is the Z. 1, 2, 3. Another Z. So the condition is in equilibrium. Then the sum of upward forces must be equal to the sum of downward forces. Or we can also say that, okay, what they want us to find is the value of T1. The value of T1 or T2, I'm going to say opposite over hypotenuse. Now, remember this is 100. 100 is still here because that is the line of action. I'm using it as my vertical. Even if I use the triangular rule, yes, triangular rule, I will still achieve this. So I have this. This is what I have now, 100, 60, and T2. So this implies that T2 is going to be cos 60 is going to be 100 over T2. So T2 is going to be 100 over cos 60, and that is going to be 50. Right? Let's check, because cos 60 is going to be 0.5. That should be 200. That should be 200. Because cos 60, yes, is 0.5. 100 divided by 0.5 is 200. Please don't mind me. All right, this is 200. This is 200 Newton for the T2. When we go to T1, When we go to T1, I'm also going to just do these simple trigonometric ratios. And that means my 145 degrees T1 adjacent over hypotenuse. So cos 45 degrees is going to be 100 over T1. So T1 is going to be 100 over cos 45. No, cos 45 is a special one. It's not. I have cos 45 0.7071 100 over 0.7071, and that is 100 divided by 0.7071, 141.4. 141.4 Newton. Do I have anything like that on this? These people, okay, let's look at the options. Option A, there is no 200. There is no 200. So once I see 200, I know I'm correct. Option 2, there is no 200. Option 3, there is no 200. None of the above. I am choosing none of the above because none of them has my force, 200 Newton. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.